In this video, I want to start reviewing the different approaches to fairness in machine learning as applied to this example. So the first approach to fairness that we discussed was just various observational metrics. So what do I mean by that? So you build this kind of system, so you figure out all the A0s, A1s, A2s, B1s, B2s, and so on that you don't see here. And then based on that, what you're able to do is you're able to take all the statistics that you want to take, and maybe you don't want to take the male statistic because you want to be just blind to that. Maybe you do. And then from that, you predict maybe the future number of accidents that the person will have. And based on that, to simplify matters, you assign either a high or a low premium as opposed to like a real number, because that will make things more difficult for us in terms of discussing the various fairness metrics. Although obviously you could also figure things out if you assign a premium that's a real number and not just high and low. So what are things you can check for? So one thing you can check for is accuracy parity. So what does it mean? It means that regardless of gender, for each individual, you have the same chance of getting things correct, of predicting that they need to be charged a high premium if they're going to have lots of accidents, or a low premium if they're not going to have accidents, and you're going to do it kind of with the same accuracy regardless of gender. So that is our protected characteristic here. You can think about it in terms of the false positive parity, right? So here, all we care about is about charging people high premiums when really they're not going to end up having lots of accidents. That seems unfair, and it seems unfair if you do that at different rates to different demographics. So this would be false positive parity, and like we saw in general, you cannot have both this and this, right? So you got to choose unless across all demographics, the base rates are the same, so people regardless of gender have the same number of accidents. That's just not true, so men have substantially more accidents in general. You could aim for demographic parity, and demographic parity here would mean that regardless of demographic, the same proportion kind of within each gender is charged high premiums. Again, this is only consistent with accuracy parity and false positive parity if your base rates in terms of what's going to happen in terms of the number of accidents are actually equal across all demographics. Otherwise, you got to choose. You cannot have all of those. Now, you don't have to stop there. So just because you determined that your system is unfair according one of those metrics, and which one of the metrics you want to use, that is kind of a complicated policy matter that you need to think about. So what you can do is you can say, okay, so I'll just adjust the way I assign the premiums accordingly so that the metric that I want to satisfy is satisfied. And you can imagine how you would do it. So you would say, well, I'll just kind of I'll get kind of some kind of prediction here, and then based on that I have a formula for deciding what's going to be a high premium, what's going to be a low premium. So I'm just going to adjust the formula for different demographics so that my fairness criteria are satisfied. So that is observational fairness criteria, and what you can do about trying to satisfy them.